So hi everyone, and hi everyone on Teams. So my name is Ariana, and I've been here at Queen Mary for the past 2 weeks about. So hopefully I've met some of you before, some maybe we haven't crossed paths, but nice to see you before I head out. And I'm really grateful for this opportunity to share a bit about my research that I do at the MTG. And so I'll get into it. So just to start off a bit, let me get my controls. To give a little context for the type of research that we're doing with music, I wanted to provide a little bit about what motivates it, which is the fact that mental health has been increasingly a growing issue, and there's limited resources to really be able to manage that on a scalable level. Over 1 billion people worldwide are now designated as having mental health condition, according to the World Health Organization. And a lot of time people are searching for, some type of resource to help them. They use music often as that type of resource. But it's often self-guided, unintentional, or maybe couldn't be beneficial, could also not be beneficial when it's kind of self-medicated in a way. So how can we use technology to make music as a therapy more intentional and also more scalable? It's kind of what motivates the research that we do. So recently we did a survey of music therapists, right? Because there's this industry of music as a therapy. To understand, what is their approach and how do they use technology today in their practice. Interestingly enough, according to a study studied music therapists over the past decade, their increase in technology use has been on the rise. And so that's kind of where we wanted to do these one-on-one interviews to understand, okay, but how, right? And what's the type of technology that they're more likely, more open to adopt. And two core needs emerged. One being accessible therapeutic music generation. And they mentioned that they're looking for music to accompany them for improvisation, for emotional oriented controls, and for really intentional composition, structural composition, not just like a loop. Also, they wanted some kind of technology to help integrate the physiological monitoring of patients and that management of, their content that they provide to their patients. So kind of a place where you can apply computational neuroscience and biomedical research along with music and therapeutic aspects. So really the current state is a lot of times, as much as there is this openness towards technology, there's also still a skepticism when it comes to AI and digital tools, because obviously they don't want a technology that's going to replace therapy. They want a technology that's going to help support them in extending their practice. So even though we know in the future state there's this capability for music to help enable creative expression, to provide real-time feedback and support the aspects of music that we fundamentally know help as a therapeutic measure, which is neural entrainment and kind of this training of our brain. We also know that there's an ability to lower the barrier for entry for non-musicians. The true gap exists that there is still a lack of technology that is meant with the therapeutic intent. If you think about our generative music technologies, a lot of time it's this one-shot prompt, see what kind of funny song you can create, but how can we really tune this to be something for a specific intention? So that's kind of where our research is going. So I'll pause there as far as context and I'll introduce myself a little bit. So hi, I'm Ariana. I'm a musician and I once dreamed of studying music therapy, but walked out of my undergrad with a bachelor's in finance. A little bit of a weird turn. I ended up working at Goldman Sachs for 4+ years until one day I decided to call it quits and pack my bags and I moved to Barcelona and I'm now pursuing a master's in music technology. And there I get to work on a really fun project called Musictopia that combines music, technology, and well-being, kind of coming full circle to the original intent that I had of studying music therapy, but by powering it with technology. So Musictopia, this is a web-driven platform, obviously it's research-backed as well, that provides accessible music-based tools for mental health and emotional well-being in a way that adapts to the user in real time. So we have a core team of researchers, including our Professor Rafael Ramirez, a PhD student Raquel, and Mario Ortega, who's our tech lead. We also collaborate with a lot of other organizations, such as music therapists in Catalonia. They have an Asociación Catalana de Musicoterapia, who help us kind of inform the tools that we're making so we know that it's developed to support their practices, not replace. We also are working with the Barcelona Music Lab, and we work with a tech accelerator, Music Tech Europe. And so on the side, you'll see some of our features that we have available on the platform. So this ranges from kind of typical music-based therapies, binaural beats, soundscapes, breathing exercises. But also on the bottom, you'll see two features, which are our generative music features that we've really been developing, and really the core of the research that I've been doing most recently, which is our mood swing and ambient composer. So today's seminar will cover first, mood swing, which is a user-oriented tool that helps you create music based off drawing on a 2D emotional canvas to generate an evolving harmonic progression in real time. An ambient composer is a customizable soundscape for non-musical wellness practitioners. So trying to help with, let's say, like a yoga instructor who wants really intentional music background for their sessions. So just to start off, mood swing, hopefully you'll be able to hear this when it plays. And hopefully on Teams you're able to hear it as well. You can see the user drew on the platform and on the canvas, and that generated a progression, which is then sent to a transformer to generate a melody in real time. And it has additional accompanying components like a pad and drums, etc. So, like I mentioned, user draws on the valence arousal plane. That generates a chord progression based off where they drew and how long they drew. That's sent into a GPT-2 style transformer, which generates a real-time matching melody that's conditioned on the chord that's playing. And then those melodies and chords are synthesized from the symbolic music that's generated through the GPT transformer and played back through tone.js. So that's kind of just the overall architecture, right? But when we were designing this platform, we came into a fundamental problem, which is, okay, we're going around these emotional nodes, right? If you remember on the first screen, it's balance and arousal. We have excited or, happy. How do we associate that with chord qualities? Well, I mean, there's a heuristic approach that says minor chords are sad, major chords are happy. But how can we do this in a bit more of a computationally and data-driven scientific way? Well, we have two kind of competing constraints that objectives we want to achieve. So we want something that's emotionally meaningful in the way that we map it according to balance and arousal. But we also want something that, since the user is going to draw in this continuous cycle, we want something that's musically meaningful, not just minor, minor chord until they get to the major region, right? We want something that kind of has an overall progression that is sensical. But this kind of has to deal with two competing other aspects of it. If you go too far in the emotional meaning, it could be musically boring. And if it's too musical, maybe there's no emotional orientation behind it. So we wanted to balance both objectives simultaneously. So we devised this experimental pipeline where we used a toolkit developed by another researcher who works in psychometrics, which is called Song Sense Score. It uses clap embeddings to essentially create like an emotional estimation for an audio in the balance and arousal planes. So we get kind of coordinates for that. We use that and create an emotionally organized chord progression to go around the circle. And then we score that with a musicality scoring that we generated and get to our ultimate multi-objective optimized chord progression. So I'll go a bit into that, and we'll probably come back to this graph a bit in a bit. So just to explain how we do that estimation of emotions, right? It's using clap embeddings, and if you're familiar with clap or contrastive learning for audio pre-trained, yes, clap is very popular. So essentially what you're doing is you're taking chord audio and comparing it to text classifiers. Those 4 text classifiers are high arousal, low arousal, high valence, positive valence, negative valence. And essentially by using the pre-trained weights in clap, we get like a probability of, okay, here's an audio. How close is it to the text high arousal? How far away from it is low arousal? And from that, we can kind of compute the coordinates comparing the two probabilities. So from that, we were able to kind of map it all into a space, into a latent space or 2-dimensional space. And from that, we kind of ordered it around a centroid to create a progression in order that kind of organizes it similar to the balance and arousal plane. But interestingly enough, so when we were going from a symbolic representation of music, chords, to audio that we'd feed into clap embeddings, we had to synthesize it, right? And so then you have this process of, well, are chords experienced in isolation or are they experienced in context? Mostly they're in context. So we did both just to test what would be the difference when feeding into clap a chord played with a little bit of reverb from the previous chord versus a chord just in isolation. And interestingly enough, some of the chords stayed put in place, so it kind of showed like a stronger presence within that valence and arousal space, or stronger probability that it's aligned to that coordinate, versus others that had in context audio where some moved around a lot more. So kind of shows that further research maybe should be around chord progressions in general as opposed to isolated chords. Nevertheless, we saw major and minor chords clustering, so it definitely started to align with the heuristic and perceptual approach that we have to chords and emotion mapping. Additionally, we came up with a musicality scoring methodology. So it's kind of following a lot of voice leading and principles that you see in typical musicology. So talking about kind of like how far are the pitches moving between one chord to another. If they don't move that far, then maybe that's like a good musicality approach to say, okay, you're not too disruptive or like, yeah, moving too jarring of a transition. Additionally, how many common tones do you retain? And do you have any kind of those typical like resolution core tones that you see, like a five chord moving to a one, that has like certain tones that are typical in Western music. So combining all that together, we have a musicality scoring. We can get some arbitrary scoring number that we can apply to these chord progressions. So then we applied an optimization function, right? Simulated annealing. So basically what we're doing is we're generating random chord sequences and evaluating them based off of a musicality scoring that we have, and then also an emotional scoring. And the way we scored the emotion was by taking that original emotion-oriented organization that we got from the clap embeddings and compared the generated chord progression to that, computed a circular index distance to basically say, rotate it in all different directions, since a progression could start on any point, but it's the same thing. To see, okay, how far displaced are these chords from one another? And overall, we end up going through kind of like repeated of randomization, scoring, see if you can score better and better through different generations. And so you come to a convergence of the most optimal progressions. So from that, we got 3 optimized progressions. Kind of these are the top 3 scoring. And you'll see across like the musicality scoring and similarity to the emotional plane here, they kind of also are scored very similarly in place. So basically our scoring functions were like, yep, these are the best, and there was not much else to it. But what we did notice too here is that when you look at now in context and single, those are the lines that were related to the chords we sent to the clap embeddings, like the organization. It was interesting, they have certain areas where they scored really well in regards to musicality and some of the aspects of the musicality, but others where they scored lower. So it kind of shows how, the emotional ordered bass lines kind of struggle to manage musicality as well. Like there is that inherent push and pull between the two objectives. And that musicality is a multi-dimensional objective within itself. And so maybe there is more to kind of explore in the constraints that brought us to that place. So looking at these kind of chord progressions, the optimized chord progressions versus the just musical bass lines, something interesting here. So this is that similarity scoring that we did, kind of seeing which ones are similar, which ones are not. Between the optimized scores, you'll see they're actually not that similar to each other. So even though they scored very similarly in their arbitrary musicality number and arbitrary emotion number, right? They still were like very different in their own orderings, which means like within this kind of like optimized space that we created, there's multiple like local minima that you can end up in with our function. And so maybe that's what taught to us that we need to kind of further refine how are we scoring emotional optimization, how are we scoring musicality, so we can really refine into something that's much more kind of like a global minimum or a global convergence into the best optimized approach. So that was like very interesting that they were different from each other. And also very interesting that the single chord emotionally organized chord progression was very similar to the optimized chord progression. So kind of showing that we were already on the right path with one of the emotionally oriented chord progressions. Okay. And so, and along with all of this research, right? Okay, we're doing a lot of computational data-driven approach, but what do people think, right? Like, machines can tell us all they want to tell us, but does this align with what people experience? So we did a human study. We gave humans chord audios to listen to and asked them, rate this on a level from 1 to 7 of energy, rate this on pleasantness, representing arousal and balance. And what we saw is that the organization of chords was actually very different than the ones that we got from the clap embeddings. So goes to show maybe there's some bias in the clap embeddings or some general incongruency between that and those that we surveyed. But additionally, within the survey results, there was a lot of inter-surveyor disagreement, which specifically within the balance realm, whereas arousal, I think, is a little bit easier for everyone to kind of come to the same conclusion because arousal is typically associated with, okay, do you have high energy or low energy? Is this loud or soft? It's like very basic. You can almost extract audio features and be done and be very close to it correlation-wise. But balance is harder to kind of put a finger on when you think about it from like a audio feature extraction perspective, right? Because like what makes something sound pleasant to you might not be pleasant to another person. It's inherently subjective. And so that's kind of where we realize, music emotion is subjective in its nature, and the design should support exploration and maybe not one fixed optimal mapping. And additionally, with the musicality, we asked raters to kind of listen to chord progressions going from one chord to the next and rate it, how musical did this sound? Was this a smooth transition? Was this a shaky transition? And interestingly enough, based off of what we had scored as musical in nature versus the human perception, often diverged as well. So kind of showing that maybe what we had put in as the musicality scoring ended up being a little too maybe boring, honestly. No, we had a lot of these like rules that had, same tones. So if maybe the function ended up just like kind of converging on like 1 1 1 1 1 kind of result, you have the same note over and over again. And that to a computer is musical, but to a human is not. So that was very interesting as well to kind of see the strong divergence. So ultimately, our key takeaways was just that like emotion and musicality are competing design objectives, but through optimization, we were able to get to kind of a better place with that, and trying multiple different solutions within the combinatorial space. And additionally, kind of using these data-driven approaches can help us kind of create multiple possible outcomes, do some more exploration within the space, maybe something that wouldn't have come to us naturally through our heuristic approaches. And that's what we're kind of like coming to the conclusion of, when designing these tools, often we look from a scientific perspective of like, what is the right answer? But science, it's subjective at the end of the day, right? So it's more of, maybe we should align ourselves more with the perceptual principles of what is perceived to have the right outcome that we're looking for, which is just emotional support and well-being, right? And adapting to kind of the listener's perception, maybe making these rules more personalized to each person. And so, yeah, future directions will kind of look into kind of doing that more perceptually driven, extending to a larger chord vocabulary or more precise and targeted musicality scoring, and additionally kind of exploring more of Musicopia's broader toolkit and emotional sensing. So that was a bit on mood swing, and I'll go next into our second app, which was more about kind of the helping a non-musical wellness practitioner to be able to have kind of a musical soundscape. So this is the tool, and essentially what we did is we decomposed the ambient music into 5 instrumental layers, and gave you kind of parameters to control the timbral aspects that are more intuitive to kind of a non-musical listener, so warmth and brightness. And additionally, we have the mood selection at the top, which is where you set just a chord progression with a mood. And in this, we had more of this kind of approach where we were saying, like, let's look at the overall, like, evolution of the chords and the resolution tones that you experience in the suspensions and associate that with a mood more heuristically, since we kind of went down this whole rabbit hole, specific chords to emotions, and it came out kind of inconclusive. So I'll skip along. So like I was saying, we have in this tool, the user selects global parameters related to the mood, and that sets the chord progression that's for the song. Then they're able to toggle kind of the presence of the different layers. And this is very similar to kind of some of the soundscape customized soundscapes that we see out on the market today, having multiple layers that you can kind of adjust the presence of to kind of configure it to your own desire, and then also configuring each layer independently in its own timbral aspects. Then the second component, once the user has created this kind of looping sound that they like, we have like an auto sound journey generator, which essentially creates different variants of what you've created just by changing the mix, right? You could see the levels changing in each of the 5 sections of the song. So essentially doing kind of like what a music producer does, right? Like taking a full loop and with many different layers and then slicing them back, cutting them here, putting them in, kind of doing the dynamic layer mixing. And kind of the idea from this came from doing myself, composing some songs for some music therapists that we were recording and collaborating with. And this was very much following my creative process. So this has kind of been like a bit of a brainchild of mine since working, kind of trying to simplify the DAW and not give someone a whole Logic Pro kind of a tool, but reinventing just the simplest bits that allow for customization. So like I said, this is kind of just on the mood presets and how we associated each of the chord progressions with the kind of harmonic tension, resolution, and predictability that is used and often associated with evoking a specific listener experience. And in this is where we're kind of applying some of the lessons from the previous research where we're using more in-context chords for emotional indication as opposed to single chords. So yeah, so that's about a summary of the work that I've done. I guess ongoing work is continuing to refine that tool that I just showed you, kind of getting more user feedback, having it used in practice, see if we can enhance the interface to be more intuitive for non-musical users. Additionally, doing some kind of EEG and neuroscience, computational neuroscience-based research. That's what I'm specifically working with Iran on, is understanding like the neural encoding of musical surprisal, because we've seen surprisal associated with the perception of pleasure, right? And so kind of maybe going down this rabbit hole of like, what is balance? How do we measure balance? If we can incorporate physiological results like EEG, maybe we'd be able to see how we can kind of get closer to the alignment without actually having to do like a questionnaire to someone and say, okay, what was your balance? You know, how much did you like that? And we're also doing a study back at UPF right now. We're recording some EEG data sets of people listening to binaural beats. So that's going to be a fun one to explore once the data is collected. So yeah, that's my research, and I'd love to get questions and thoughts and opinions. And also, if you're curious, feel free to explore Musictopia.